This tutorial is going to walk us through how to use DFM concurrent costing to analyze an injection molded part. I've gone ahead and loaded a picture in here of a sample injection molded part. This happens to be a STL model of a part, but I've just done a screen capture and put that into the picture box here so you can see what we're analyzing. It's got some envelope dimensions, it's a simple box shape, and it's got 3 holes in the bottom. We're going to mold this out of ABS. I could also have imported the CAD geometry using the CAD import feature that's covered in the import a CAD model into DFM tutorial that you can also download from our website, www.dfma.com. So given this as the example here, what I would do is I would call it here the plastic cover. I'd give it a part number, and I can specify a life volume. Maybe we want to mold 250,000 of these parts. Now it's obviously the hollow box shaped part. It's 2.756 inches tall. It is 2.362 inches wide, and it's 4.449 inches long, with a section thickness, a wall thickness on average of 0.79. Now Z is the appropriate choice for the direction of tool motion. I would open and close the mold in that direction, therefore getting those holes in the bottom of the part, not requiring any side actions on the tool. Now I press this button that says Select a Process and a Material to bring up the Process Material Selection dialog box, where I'm now going to choose the manufacturing process and material. So here I'm going to pick injection molding, and you'll see the materials turn red and green to indicate to me which materials are and are not appropriate for the manufacture of this part using this process. So under plain resins here, I'm going to pick ABS as the material I want to use. So when I've selected a process and a material and they're both green, or I've selected a process and a material and they're yellow, and I'm willing to accept the process limitation that is being described to me, I say OK. And the software will go ahead and calculate for me a cost, 29 cents at the piece part level, with $33,348 for the tooling. Now that calculation of the cost at this point is based on a guess of what these values are based on the envelope dimensions and the envelope shape that we specified. And it's up to us now to go through and refine these inputs to better calculate what the actual cost of the part would be. Now I can change anything I want, and I can click Calculate to see the impact of that. So right away, let's change the batch size here to 12,000 pieces. The default batch size is set to 1/8 of the life volume, so that's where that number came from. If I change that, it colors the field blue, and when I click Calculate, I can see that that really had no influence in cost at 2 decimal places of precision. It actually took my setup cost from something less than a penny up to a penny as a result of that change. I could change the plant efficiency, the regrind, the scrap value, any of those values. And then I get to these geometry inputs. Now, if I know them, I can type them in. So if I know this part weighs 0.15 pounds, I could type that in there. If I had, again, imported the CAD model, these values would have been extracted from the model for me. Or in this case, I'm going to show you how to use the geometry calculator to go about building up the geometry of that part. Well, we're starting fresh here. The envelope dimensions that we entered at the top level are not assumed to be the default when we start. So I got to start with a block, and I want to pick this yellow box here and tell it it's got a 0.79 wall. It was 2.756 tall, it was 2.362 wide, and it was 4.449 long. The projected area direction is in the Z direction here, so that's going to be influential in the calculation of the machine size. And then to get the volume correct, I had those 3 holes in the bottom, so I'm going to pick a cylinder here, tell it that it's negative, it's 0.079, and those holes are about a ½ inch in diameter. Again, the projected area is in the Z direction, which is going to subtract from the amount of press force that's required. And there are 3 of those that are in the bottom of the part. Now if I pick the part level here, you can see the volume and projected area that the software has calculated. And if my shape was more complex, I would use these other shape classes here to build up the volume and projected area of the piece I was looking at. I then go to the geometry menu, I select Transfer and Close, and that will color those fields in blue for me to let me know that those have now come from the from the geometry calculator. I can click calculate. I can see the impact on the cost is still negligible at 2 places, so the guess that the software had made in this case was a pretty good one initially. Finally, this value of surface patches needs to be edited. And if I click in the field and bring up the help system, and I click this link to complexity, you can see here some descriptions of surface patches. Surface patches are a count of the surfaces on the part, and they're used to estimate the tooling cost. So we see here this shape, it's saying has 6 surfaces, 1 here, 2, 3, 4 on the bottom, 5, 6 on the back side. So if I go around and I count up the surfaces on my box, it actually looks an awful lot like this one. So we start out with 10, but then the inside of each of those holes would count as 1. So I'd have 3 more, or 13 surfaces on this box. So I'm going to change this value to 13, and we're going to see a fairly significant impact on the cost of tooling. We've gone to $12,500 now, but the software also has this algorithm that automatically selects the optimal number of cavities, and that value is now changed to 4. Based on 4 cavities, the software has selected this machine that is the least expensive machine that's capable of molding this part. And then it's down here at the bottom level showing us the calculation of the cycle time. So that cycle time is the cycle time to mold this part based on the section thickness of ABS that we've specified. That time multiplied by this rate for the machine is translating into this process cost. And then up here at this level, that part weight at that material cost with that regrind and that scrap value are resulting in this material cost contribution to the 26-cent piece part cost here. Now again, I could continue to refine this by changing the material costs, the machine rates. I could right-click on the machine and change the machine. If I've added machines to my library, I could select different suppliers and see what the costs would be at different supplier regions. But at this point, once I've gone through and verified all those inputs, changed the values to the ones that I want to be appropriate, I would have a representative manufacturing cost here for injection molding this part from ABS.